Okay, this is 7.EE.3, 7th grade expressions and equations 3, video 1, solving one-step equations. This standard tells us that we're going to be solving real-life mathematical problems using these ideas of um, positive and negative rational numbers. And before we get into solving those real-life problems, I thought maybe a review of solving these equations in one step would be a good place to begin. We spent some class time reviewing the integer rules for your negatives and positives of the 4 operations, and I think now is a really good time to review this one-step equation. We'll move into 2-step equations, and then we'll apply all of this to some real-world problems. A few terms to know. I'd like you to copy these down in your journals and define them. We're going to begin with the subtraction property of equality. I have a lot of letters on the board. Basically what it says is I'm going to take this first statement, x plus a equaling b, and this arrow means I'm going to work out the inverse operations when we're solving for this missing variable of x. So right now, x is the letter that we are solving for. A is a constant value, and we need to get that constant value over to the other side. We're going to balance our equation by doing the opposite of adding A. And if the opposite of adding is subtracting, so we have adding A, subtracting A, and to balance the equation, whatever we do to one side of this, I call it a wall or the equal sign, we must also subtract A from the other side. All right, so let's look at this in a few examples. We're solving for C. I think you can figure out what C would be if you add it to 5 to get 8. Okay, yeah, your answer is 3. Now, if we had to do this algebraically, how's that going to look? All right, so we have C added to 5. The inverse operation of adding 5 is subtracting 5. Whatever you do to one side of the wall, you must do the same thing to the other. So we have that 8 and we subtracted 5. So C is equal to 3. Why? This positive 5 subtracting 5 gets you 0. So that's gone, and I'm left with my C. And then on the right, I have 8 minus 5 getting 3. Okay, the second example, all I did here was I kind of rearranged the variable and the integer on the left side there. Just know that you have to look at the signs that are in front of each term. So if I'm looking at this 6, the sign in front of it is positive. Let's use a different color here. The sign in front of it is positive, and I need to get rid of that positive 6 because I'm solving for P. So how do we do that? Well, we're going to do the opposite of adding 6. So we have adding 6 subtracted by 6 plus P is equal to that right side. Now, what did we do to get rid of this positive 6? Well, we subtracted 6. So I do that to both sides. All right, here's my wall. This is now 0. I'm left with P equaling negative 11 minus 6 is negative 17. And that's where remembering those integer rules is going to come in very handy here. All right, now we have the addition property of equality. Same idea. The variable that we're solving for is x. So if I have x subtracted by some constant a equaling some constant b, in order to solve for the x, I need to get this negative a over to the right, and we're going to use the inverse operation of subtracting that a. So the inverse of subtracting a is adding a, and whatever I do to one side of my equal sign, I must also do to the other, and that's where that adding a comes in with the inverse. All right, a couple examples. Y subtracted by 12 equals 9. So think about what that number might be in your head. Think about it mentally. And You know, if the numbers are too large or they start throwing a bunch of negative integers at you, then the steps of this process are going to come in really handy. So let's take our y, stabilize our y. I have minus 12. The inverse of subtracting 12 is adding 12. And then whatever I do to the left side, I'll take that right side and do the same thing. All right, so negative 12 plus 12 is 0. That's exactly what I wanted to do. And 9 plus 12 is 21. So is that true? If I were to substitute in my y is 21 subtracted by 12 equal to our 9, and that would be a yes. All right. Next example, I have kind of a multi-step equation here. I see on the left side of my wall, I'll draw my wall all the way down, I have two constants of 6 and negative 4. And we've talked about combining like terms in our expressions, so let's start with that. If I were to take 6, it's a positive, right? Look in the front sign. Positive 6 and a minus 4. 6 minus 4 is positive 2. There's my x, and there's my 8 on the right side. All right, so now we just kind of simplified it a little bit further, and now we're going to follow our order of operations. And let's solve for x. So with our x, we have this positive 2. So to undo the positive 2, we need to get rid of that to solve for x. So the opposite of adding 2 is subtracting 2. So there's our 2. Let's subtract 2. There's the x. Let's balance it out. I have my 8. What did I do to the left? I subtracted 2, so I better subtract 2 over here. All right. 2 minus 2 is 0. X is equal to 6. Let's check our work. I have positive 6 plus my x. What was my x? 6 minus 4. Is that equal to 8? Let's check it out. 6 plus 6 is 12. 12 minus 4 is 8. So yes, it checked. All right, now we have the division property of equality. And like I said, some of these properties look very scary with the way they're written out. Basically, what we need to do is solve for the x variable. Again, we have this a that's attached to the x and this b on the right side. Special note, a cannot be equal to 0. All right, so on the right side, basically what we're doing, if we're solving for x, to undo, this is multiplication right here. This is a product. Anytime a number is touching a letter, we are multiplying. So the opposite of multiplying now is the dividing. So we're going to divide both sides by that a, divide both sides by a, and then you should simplify your answers. Let's take a look. All right, so some number x multiplied by 6 is 54. Mentally figure that out. If the numbers are too large or you have some negatives, here comes the process. 6 touching a variable, if I'm solving for that x, 6 touching a variable is multiplying. The inverse or opposite of multiplying is dividing. So we're going to divide both sides by the coefficient. What number is touching the x? Well, the 6. So x is equal to 9. All right, same idea, except we have a negative coefficient. Negative 3 touching the t. The opposite of multiplying is dividing. Divide by the coefficient. So t is equal to positive 3. All right, last property, multiplication property of equality. So now we have this fraction bar saying some number x divided by a is equal to b. A cannot be 0, We don't want a in the denominator. That would be an undefined fraction. And what they want us to do is they want us to multiply both sides by a, because the opposite of dividing is multiplying. And what are we dividing by? We're dividing by a. So let's do the opposite and multiply both sides by that a. All right, it's a little easier when we look at the examples. So in the example 1, I have some number divided by 2 is equal to 8. Well, what number divided by 2 is equal to 8? All right. Do the opposite or inverse. The opposite of dividing by 2 is multiplying by 2. So we'll go, since this is in fraction form, we can put this in fraction form. We don't have a fraction on the right, so we could just keep it at 2. All right, so your 2's cancel. You're left with x over 1 equaling 16. And anything divided by 1 is equal to itself. So x is equal to 16. Or you could have quickly multiplied straight across your equal sign. 2 multiplied by 8 gives you your 16. All right, the last one's a little trickier. Now we have a coefficient of a fraction touching a variable. And this is where the reciprocal comes in handy. So anytime you have a fraction touching a variable, to get rid of that fraction, we want to multiply by the reciprocal. We want to turn this into 1y. So how are we going to get a 1 out of that? Well, the reciprocal of 3/4 is 4/3. And we have to do that to the right side also. So 4/3. We could put this over 1. All right, now look at what happens. The 4's cancel the 1's, the 3's cancel to 1's. I'm left with my 1y, and now I just have to answer the right side. Okay, so we can cross cancel. 3 goes into 3 once, 3 goes into 12 4 times. Okay, 4 times 4 is 16. 16 over 1 can simplify to plain old 16. Oh, I didn't plan that. Look at it. Both answers are 16. All right, in your journals, I'd like you to define the given terms on page 2 of the flip chart. Write down a few sentences on what you learned from this video. Any questions, please bring those questions to class. This is a review from last year. I believe you solved some one-step equations. We are building our way to two-step equations and then the standard. We want to apply those ideas to real-world examples involving rational numbers. I'll see you in class.